Welcome to chemistry class with Emera. In today's class, we are going to be looking at electrolysis. In the first part, we look at the definition of electrolysis, electrolytic cell and its components. We look at the Ionic theory, and of course, factors affecting the preferential discharge of ions during electrolysis. First and foremost, let's define electrolysis. Electrolysis is the chemical decomposition of a substance in molten or aqueous state when electric current passes through it. Chemical decomposition, underline the word chemical decomposition of a substance in molten or aqueous state. Underline the word molten aqueous state. That's a condition when electric current is passed through it. That means we are converting electrical energy to chemical energy. Of course, from the word electro and lysis. Lysis means decomposition, electro means electricity. That means when you pass electricity through some chemical substances, they break down as a result of that. So that is generally what electrolysis is. Of course, it's different from electrochemical cells that we are going to consider after now. And of course, after this definition, let's look at a simple electrolytic cell. This is the diagram of a simple electrolytic cell. In the electrolytic cell, we have the container, we have the electrolyte, we have the electrodes, the anode and the cathode, and the battery source. Battery source is where the electrical energy is coming from, and of course the electrolyte is usually a chemical substance that decomposes when electricity enters into it. An electrolyte is a chemical substance which is always in molten or aqueous state, and of course it decomposes when electric current passes through it. For the electrodes are substances through which current enters or leaves the cell. They are substances through which current enters or leaves the cell. And of course, we have two types of electrode. We have the anode and the cathode. The anode is the positive electrode through which current enters or leaves the cell. The cathode is the negative electrode through which current enters or leaves the cell. When ions migrate to the anode, they become anions. That means anode ions. They are usually negative. Don't forget that unlike charges attract, like charges repel. When positive charge enter the cathode, they become cations. That means cathode ions, they are usually positive. So this is generally the electrolytic cell. And of course, quickly let's talk about the Ionic theory. Let's talk about the Ionic theory. The Ionic theory was postulated by Arrhenius. For the Ionic theory, let me break it down into four things. Number one is dissolution. Number two is ionization. Number three is migration or polarization, and number four is deposition. So for you to, the summary of Ionic theory is based on this. Number one, the theory believes that when a solid substance is dissolved, now when you dissolve it in water, a solid substance is dissolved in water, of course it becomes molten or aqueous. When you dissolve a substance, most especially a salt, an acid, a base, which are usually used for electrolyte, when you dissolve them in water, they become aqueous. Okay, so when they become aqueous, they turn from being an ion, an atom, to ion. For instance, in ionization, when you have NaCl, for instance, you dissolve it in water, you are going to have we are going to have Na plus and Cl minus. This is ionization, whereby the atoms become an ion. So ionization is a process by which atoms become ions, the process by which ions are formed. That is ionization. Ionization usually occur when there is dissolution, when some substances are dissolved in water. So the oxidation state has moved from 0 to +1 and to -1 respectively. So that's ionization. Now when this salt is ionized, and of course you now introduce electrodes. When you introduce electrodes, there is now polarization. The positive ion goes to the negative electrode, while the negative ion go to the positive electrode. That's polarization or migration. So they find their poles, the appropriate poles to go, and then they move there. So migration or polarization. And then the final one, immediately they get there, they form they deposit on those electrodes. So this is basically the summary of the ionic theory. Okay, so we'll also look at the factors for preferential discharge. Factors affecting preferential discharge. Preferential discharge during electrolysis. There are 3 factors. Number 1 is the position of ions. Number 2, concentration. And number 3, nature of electrodes. These are factors that affect preferential discharge. In electrolysis, when electrolytic reaction is happening, usually have, let's assume you have electrolysis of sodium hydroxide, for instance, or let's say sodium chloride, dilute sodium chloride. So in electrolysis, you usually have the salt and then you usually have the water. So in this case, the ionization is Na plus, Cl minus, and then you have H plus, OA minus. So in every electrolytic reaction, you have 2 positive ions and 2 negative ions. So in that solution, so there must be preferential discharge. One will have to be discharged, while the other ones will have to be left. So how do we know, or what are the factors that govern which one we are going to pick? Number 1 is the position of that ion. For the 2 competing ions, the position matters. The ions that is lower in the activity series are preferentially discharged. Ions that are lower in the activity series are preferentially discharged. Now let's take for instance sodium and hydrogen ion. In the activity series, hydrogen is lower than sodium. You can go ahead and check your activity series under electrolysis. Okay, so master it. It's important that you master it. Hydrogen is lower than sodium, so in this case hydrogen will be preferentially discharged. The same thing applies to chloride ion and hydroxide ion. Hydroxide is preferentially discharged because it is lower in the activity series. So the ones that are lower in the activity series are preferentially discharged during electrolysis. That's number 1. The second one is concentration. For concentration, caution must be taken. Now, for concentration to hold, number 1, if the ion that is concentrated, or the 2 competing ions, let's assume you have sodium. I'm using sodium chloride again. In this form now, we have concentrated sodium chloride, which is called brine. So this one is brine now, a concentrated sodium chloride. And then, of course, I told you water will also be there because it's an aqueous solution. You have Na plus again, Cl minus. You have H plus, OH minus. Now when we want to consider, don't forget that this sodium and chlorine are concentrated because we are looking at concentrated sodium chloride. Now in order to pick the one that is preferentially that will be preferentially discharged, for instance, sodium and hydrogen are far apart in the activity series. The distance between them is much. So despite the fact that the more the concentrated ion, the more is preferential discharge. However, if the distance between the concentrated ion and the other competing ion is far apart, and the other competing ion is lower in the activity series, the other one will be preferentially discharged. In this case, we are looking at this. Hydrogen and sodium, sodium is they are far apart in the activity series, but hydrogen sodium ion is concentrated, but because of the distance is much, hydrogen will still be preferentially discharged despite the fact that sodium is highly concentrated. The concentration only holds if the distance between the concentrated ion and the other competing ion is close, so the concentrated ion will be preferentially discharged. Okay, now in the case of these two, the distance between chloride ion and hydroxide ion is very close. So since chloride ion is more concentrated than this, in this case chloride ion will be preferentially discharged. That's the difference. So concentrated ion are preferentially discharged if the distance between the concentrated ion and the other competing ion is close. If they are far apart, we use the first one, the position, as the judge. So I hope you get that. Then number 3 is the nature of electrodes. In this case, I define I give 2 types of electrodes here. We can have the active and the inert. For instance, in the same electrolysis of, now let's go back to dilute sodium chloride now. In the electrolysis of dilute chloride, our choice of electrode is matters. For instance, when we use platinum electrode as the choice of electrode, the electrolysis go as planned, because in this case, in this reaction, platinum PT is an inert electrode. It does not take part in the reaction. However, there are some electrodes that, because of their strong affinity for one or more of the ions that are present, they become active and they mix with the reaction, and then we do not get our product. Those electrodes that take part in the reaction, they are called active electrode. For instance, in this electrolysis, if we use mercury Hg as our electrode, it will affect the product of the reaction. Why? Because mercury has affinity for sodium. So mercury reacts with sodium to form what is called sodium amalgam. Sodium amalgam. So this number 3 factor help us to determine, we are able to determine what choice of electrode we need to use when we are performing electrolysis, or when electrolysis is going on. So in the factors affecting our preferential discharge, we have the position of ions. I have said that ions that are lower in the series are preferentially discharged. We have concentration. Concentrated ions are discharged, preferentially discharged, if only the concentrated ion and the competing ion, they are close together in the activity series. And number 3, the nature of electrodes. We have active that take part in the action. We have inert that do not take part in the reaction. So when you are choosing electrodes, you have to take inert electrodes in order to get the desired result. This is the first part of this lesson. We have looked at the definition of electrolysis, electrolytic cell, the Ionic theory, and factors. In the next video, we are going to be looking at some the electrolysis of some compounds, and then we go into laws of electrolysis and related calculation. I hope you enjoyed the video. Bye bye. Yeah, 14 minutes. 14 minutes, tonton. Okay. Then she second part. Electrolysis of má ti ṣe electrolysis kí n kọ́kọ́ ṣe àwọn loss of electrolysis yẹn náà. They will not do calculation. Mo ti ṣe loss of electrolysis nígbà kan gan. Yẹn ti àkọ́wò fídíò tí mo ṣe ná wọ́n lọ wẹ́ pé mo lọ Jones ni.